We have seen different storage devices. These different drives technologies are grouped together to form storage arrays. Typically, storage array are computer systems designed to provide storage to connected client devices over a shared network. These contain hundreds and thousands of disk drives, providing storage capacity of terabytes of data. Broadly speaking, we can divide storage arrays in three major flavors based on type of data getting stored. It can be SAN-based array storing block data using protocols like Fiber Channel, FCOE, iSCSI, etc., or NAS-based storage arrays providing connectivity using file-based protocols. Similarly, unified storage arrays provide shared storage over both block and file protocols. So, whatever be the type of storage array, their main purpose is to provide storage resources to connected host over storage network. Apart from these, arrays provide features like replication, snapshots, high availability, performance, efficiency, resiliency, etc. We will discuss about properties in other lectures. Let's discuss some of pros and cons of using storage arrays. Storage arrays provide pool of high capacity storage to different servers evenly based on their requirement. Consider a case where 100 TB of storage pool is required to be attached to 5 different servers. Out of these, 3 servers have to bear high load, while other 2 are moderately used. So, here entire capacity of array can be dynamically shared among 5 servers based on their requirement. Due to shared nature of storage array, it also provides performance benefits. In case of locally attached storage, IOPS of each disk is available only to local server. Now by pooling all disks together in array, we can make use of all disks in parallel. So IOPS are available based on requirement. Using storage arrays, storage of servers can be managed from a single point. In large enterprise where hundreds of servers are available, it is easy to manage their storage capacity at single point instead of managing them individually. Usually, storage array has minimum 2 controllers to balance load and to override any failure of controller. So, along with improved capacity, performance and management, usage of storage arrays provide features like replication, snapshots, thin provisioning, deduplication, compression, high availability, etc. We will look into all of these features in another section of this course. Every coin has 2 faces. So, despite of so many advantages, storage arrays has some concerns or drawbacks also. Some of them are: latency is one of the major concerns, which require a lot of tuning and management from storage array point of view. First, data need to pass through storage network to reach array. Now at array end, it needs to be passed through controller, and thereafter data is to be distributed in storage disk. This complete process adds up for latency in data read-write process. Lock-in is another concern which is associated with storage array. Storage infrastructure, implementation, management, and maintenance involves large investment. Now with enhancement in technologies, it is not easy to replace or migrate storage components. Although it provides a lot of benefits, storage arrays are expensive. With increase in features, storage components needs to be either upgraded or purchased accordingly. Storage array have now replaced traditional standalone storage devices with its ever-growing performance, maintenance, and security features. Now let's look into basic architecture of storage array. Typically, we can divide storage array in 2 parts, as its front end exposed to outside world for connectivity and back end to parse and store data. Servers communicate with storage array via front end ports exposed for connectivity based on protocol being handled like FC, FCOE, iSCSI, etc. Hosts can be either directly attached to front-end ports or via SAN. In order to ensure redundancy, it is recommended for storage array to have at least 2 front-end ports. Typically, these ports are on separate PCIe HBA cards. Moreover, a single HBA card can also have 2 ports, but here 2 ports will not provide redundancy. They will be used to ensure load balancing or discrete switch connectivity. Multipath I/O software controls how data is routed or load balance across these multiple links. CPU can be treated as intelligent part of storage array which contain firmware or microcode and is responsible for all processing capacity to storage array. Typically, these are responsible for I/O processing, caching, error checking, thin provisioning, compression, decompression, deduplication, etc. If CPU is mind of storage array, cache is its heart. Every data, both incoming or outgoing, has to pass through cache. So all write to array comes to cache first before getting written to storage disk in backend. Similarly, all reads from array is collected into cache before is sent to host. Now consider a case where volume of data is cloned or is to be copied to another disk. In this scenario also, data has to pass through cache only. Flash drive based storage array also contain cache but is of less use. Here, DRAM cache is used instead of user data caching. Storage drives or disks can be mechanical or flash type. In backend, group of storage disks are used to store data. This grouping can be done to number of formats to provide better performance and faster recovery options. So, here we finish our lecture on storage devices and arrays and have walked through different storage disk type and related concepts along with overview on storage arrays. Now let's quickly summarize all concepts discussed in this video. Data can be stored either in volatile or non-volatile format. Volatile data is non-persistent type but can be retrieved at faster rate, while non-volatile data is persistent in nature. Mechanical disks are widely used device having mechanical head to read-write data. Here data is written over platter surface by magnetizing it. In platter, track is each concentric ring around the platter, while sectors are smallest addressable unit in disk drive. In zone data recording, each platter is divided into zones with equal number of sectors per track. Cylinder is collection of tracks stacked directly above one another on separate platters. Logical block addressing provides simplified address space structure to get capacity of disk. Seek time is the time taken to move read-write heads to correct position on disk. Rotational latency is time taken by desired sector to arrive under read-write head. Solid-state based devices use silicon-based semiconductors. Here, data is stored in form of voltage representing binary 1 and 0. Over-provisioning is technique to hold bloat load of hidden capacity. Garbage collection is a background process to identify blocks marked for deletion or which are partially filled. Where labeling is process of effective workload distribution across flash cells. Magnetic tape-based devices provide reliable, low-cost solution for sequential load. Storage array are computer system designed to provide storage to connected client devices over shared network. Use of storage array improves capacity, performance, management, and reliability of data storage. Along with these, array also provide features like replication, snapshots, thin provisioning, deduplication, compression, etc. On the other hand, used storage array has concerns like latency, lock-in, cost, etc. associated with it. Typical storage array can be divided into front-end and back-end processes. Front-end ports provide connectivity for number of storage protocols. Inside array system, CPU provides processing power while cache manages data flow.